This is 11/11/2023. We've got a big show today at the NRBC in St. Louis. Hopefully, I'll be helping out USARC today. But today, I wanted to make an episode. I've been wanting to do this for a while. There's a study that I found that is really cool that I've actually had struggles with. I spent over 3 hours trying to trying to read this thing and develop it to where I can actually make a video on it. And I could easily have made a video. So it wasn't one of those things where I could fully understand it. So I wanted to develop this further to understand it better. But it took me a while to have the time to actually sit down and do it. So I figured it out last night. I figured out how they did these numbers. And there is all these really cool scans that they have done, that they have created 40 models for. It's a university in actual France. And so today, what I want to make sure that the audience understands, I'm going to walk you through what I'm doing, explain how we understand the tokay gecko and the day gecko from their study, from their data, because they did not make a 40 model of these animals. They have like over 40 animals, species of reptiles in this study. And they have like maybe 10, 12 4D models. So my goal today is to walk you through the study, to actually help you understand the science behind the study. And then on top of that, my hope is to actually increase your self-esteem. Hopefully you guys will be like, man, I feel so much better. I can use this for other things. I can look at these other reptiles and I can really dive into this deeper. That's my hope, is to help you guys be happier with yourselves and understand the science and have an improved self-esteem while understanding brains of reptiles. So here's that's not it. Let's see. All right. So the study is linked in the description here. Compared analysis of squidment brains unveils multi-level variations in cerebellum architecture associated with locomotor specialization. So if you go here, you can actually, for this study, it's linked in the description. There's figures you can go to that'll show you all the figures and stuff, so you don't have to scan down, you don't have to read all this. References, but you go to sections, go to data available. Is that it? Is it data? Yeah, data available. Supplement information, and you can go to source data, and it'll actually bring this up. We want to focus on these first two Was that the... And we're going to focus on these, just about 40 different ones. And on line 18 is the gecko, the tokay gecko. And line, which one is it? It's the grandiose. It's 42 is the day gecko. So, and then you want to go to supplementary information. And this second graph here shows you what landmarks are. Now, 1 through 6 is labeled T. And then if you go to page 5, you'll see this. And this is basically showing you what they're talking about. But go back up to 2. So 1 through 6 is actually the oral stock data. And then 6 through, it looks like 18 is actually the forebrain data. And then you have 19 through 26 is the actual, let me look real quick here better. Let's see. 19 through, okay, that is the white matter. That's down here below. So it's only on these. So these are also, the top left is the above view. The top right is actually the below view, looking up at your brain, at the reptile brain. And then the bottom one is actually looking at it from the side view. And so 19 through 26 is the white matter. It is what connects the front forebrain to the optic tantrum. And 26 actually is a connection area between the white matter, the optic tantrum, and the medulla. Now, your 27 through 38 is the optic tantrum. 39 through 46 is the medulla. And then your 47 and rest on is the actual cerebellum. Okay. So now that we have that established, so now you can understand this. Which is important. This is the part that was getting me, is I didn't know what angle they were using. And so what they've done, if you go down to this, so landmark 1, we go back to here, you can see it's the left, if you're looking from the top view, it's the left beginning of the oral stalk, and it's the size of the, I think it's to the next landmark, but there's actually different directions that they used. And they used this data across the whole thing to do some mapping and stuff. So it's really interesting. So we can see this at 13 is Jackson chameleon. Okay, so this data here is showing you one thing. and we go down to the gecko. So look at the Jackson chameleon, and it's all the way to 6. And then if you go down and look at the day gecko or the tokay gecko, we can see that the stalk is longer. But maybe the stalk looks to be a lot longer and just overall bigger than the Jackson chameleon, of which would make sense. Jackson chameleons don't probably tend to sniff the air. And you can find the forebrain, the 4D model of the Jackson chameleon. You can find that. They have that one. And so it's really showing you that the tokay gecko, actually the OL stock that we're looking at here with this data, the size, is showing you it uses it more. And the OL stock is when they lick something or they smell it, it's taking that data and it's transferring it into the forebrain. So we can see that the tokay gecko uses more of that information because you use it or you lose it. So if they're not using it, it's going to be smaller than if they did use it. Down here at the bottom is actually at 45 is actually the, oh God, what is that? Ball python. It's actually massive. It's bigger than the actual tokay gecko. But when we look at this 42 at the day gecko compared to the actual gecko, the tokay gecko. Okay, so that's oh wow. That's huge difference. Okay. So they're different shapes is what it's telling you, but they're about the same size, but they're different shapes. The tokay gecko and the actual day gecko have the same size OL stock. So they're taking in the same amount of data. There could be some differences there. We don't know. Hopefully maybe you guys might be able to think about this differently. But basically the tokay gecko and the actual day gecko have the same size friggin' OL stock. So they're taking the same data, but they are not the same shape. I have no idea at this time if that means anything. So that's really cool. And right below the day gecko is an actual bearded dragon. Day gecko has a way bigger oral stock, the nose, than a freaking bearded dragon by quite a bit. And so that's really fascinating. All right, let's look at the next set. So where did it end? It ended at 6. So we want 7. And then you want to go back here. So we have 7 through 18. Okay. So we said it is at 18. So right there. Okay. So about the middle of it. So different angles to it. So we can actually look down here. And then we said it's 45, right, for the day gecko. 42. 42 for the day gecko. Okay. So we're seeing that the tokay gecko looks to be a lot bigger in the forebrain than the actual day gecko. Now, the forebrain holds your memories, your imagination, your actual decision making, all these different things holds there. So right below that is the bearded dragon. The bearded dragon seems to have a different shape, but a much different shape than the day gecko. It looks to be the bearded dragon forebrain looks to be a tad bit bigger than the day gecko forebrain, but a different shape is what it's looking like. So if we look at the data like here, you're actually looking at it and going, okay, so the day gecko actually has a bigger portion here and here, but not here. So they look to be about the same because you're looking at it and going, okay. But yet, if you compare this, so the actual tokay gecko has a bigger forebrain than a bearded dragon, is what it looks like. If I'm seeing that correctly. Yeah. It looks to be just a tad bit bigger. And the shape is important because what the shape can do, like skinks, they have the longer forebrain, but it's actually quite big. And so we can go back and we can look at skinks. So 21 is a skink. 21. Yeah. See, 21 is a skink. And so it looks to have a bigger forebrain than the tokay gecko, but a different shape because there's parts of it. So if you see the data and you look across this and you see that some of it's smaller than other points, but yet overall the amount is bigger, then their brain is actually bigger, but it's different shaped. So all of a sudden you have this brain, instead of it going, lengthwise like this, it's like this. So yeah, it's really cool. So you're looking at size comparison. So if the number is bigger, that portion is bigger. So you're looking at the amount of it that is bigger than the other animal. And so you're saying that the tokay gecko actually has the ability to make, probably more curious, there's different things that you could look at here. So than a bearded dragon. They might even make decisions faster than bearded dragons. There's a lot to take in with that. It's very fascinating, and you can take from this data, since there is no 4D model of these. That's really cool. I didn't think the tokay gecko would have a bigger forebrain. Very interesting. Very interesting indeed. Okay. So now we're going to go back to this chart. And we want to look at the. So between 19 and 26 is the connections. This is actually one of the most important things our brain most likely has empathy and a lot of the creativity and the stuff that we have because of the spherical nature of our brain. So therefore, what this actually achieves is a bigger connection between the optic tantrum in here, which I don't think we call it that for the human brain, and then the forebrain, which has the imagination. And it just creates way more connections. And this bottom piece here, kind of thing here at the bottom, that's it. That's what that is. The white matter is down here. So it's not very big, but it doesn't have to be because it connects more. Well, when your brain is sectioned like this, it doesn't connect as much. It actually has to take more time. Often, like a lot of people with neurodivergency in people, maybe more like people with autism, where it's like, okay, so it's going to take this little bit longer to get us here. So let's look at that. So between 19 and 26. So there you go. So we want to look at. So they seem to have around the same. It actually looks like the day gecko has more of the white matter by by a little bit than the tokay gecko. So the day gecko has more connections between the forebrain and the optic tantrum, which is actually really interesting. That's actually interesting. So the tokay gecko has a bigger forebrain. So this means the day gecko could potentially have more emotional intelligence than a tokay gecko. That's actually something that would mean. We look right below the day gecko, and the bearded dragon seems to have a slightly bigger amount, slightly, but a different shape than the day gecko. That's really fascinating. So what did we say? It was 21 for the... Yeah, 21. Okay. So 21. Okay, so there's more of this. So go back. So they're not showing this between the actual spheres. They're showing it below. Which is important to note. So the tokay gecko could be hiding it more. But it's showing that there's more information passing between those stills. So it'd be very interesting to actually see the tokay gecko brain, because this brings up a lot of questions. In the sliver, so around 13 and 14, that sliver, does that sliver actually have more white matter between it? Because iguanas have way more of that white matter between it than bearded dragons do. They actually look very similar to a cat's brain, to like a house cat's brain. It's really cool. And that is what I'm talking about when I talk about connections. So it would be very interesting to actually see. And that's not what this study is really that good for, is to see this. Because what that could be telling us, that the stuff is underneath more, that it's bigger, is that it's actually not between the optic tantrum and the forebrain as much in that crack. It's below it, which could potentially be massively important. It means that data that's passing between the forebrain and the optic tantrum is actually taking longer to get there. If it's more connected, it's faster. They'll be able to make faster points between their imagination and their actual modeling part of empathy. So that's important to note, because that may be something to look at later. So I'll come back to that sometime. So we want to look at 26 through 38. 26 through 38. Through 38. Okay. So we've highlighted the tokay gecko, like before. And we go down and we see that 42. About the same. A little bit bigger for the day. About the same. A little bigger. So they are different shapes. The optic tantrum is different shapes for the actual tokay and the day gecko. But the day gecko seems to have a little bigger optic tantrum. That means it relies on the eyes more than the tokay, which would explain why the tokays actually, like, the shape, the difference in the possible size of the forebrain also correlates with the intake of actual data from the OL stock. And since they were about the same, I thought different shapes. That's important to note. So basically, the day gecko here is showing that they actually have a bigger eyes. Their eyes are used more than the tokay. And we see the bearded dragon is a little more, but definitely different shape, but not by much in the optic tantrum, because it's the 40, 43, and so 21. We see that they definitely have a different shape and a much bigger optic. Okay, that's really cool. So the actual the skink here is showing a bigger optic tantrum. So they use more of their eyes than the tokay. So it was something that Cody or Dakota at DK Exotics was saying about tokays, is that you literally need to make sure your hand is down and slowly move in. They don't use their eyes as much as day geckos and bearded dragons and skinks. So that's why that's important to go slow with the tokay. That's why tokays get so scared so easily. They don't fully grasp as much because of the optic tantrum. The speed is harder on them. That actually explains it right there. That's so Dakota, if you're watching this, that's it. Their actual optic tantrum is actually smaller. So you should see the day geckos having more response than tokays to sight. Probably faster reactions, They could potentially have more emotional intelligence. Maybe the tokay gecko may actually have more emotional intelligence, but it also doesn't have the sight. That's really interesting. This is why this is so important to be comparison. And I hope that you guys see this and you guys can go through this data and start looking at these things and realizing, okay, so if the size is bigger as you go down the list and you see the numbers are usually bigger than that number for the two species, then that species has a bigger part of it. And so if that species is a bigger part, they use it more than the other species, is kind of what it's saying. But different shapes as well. If there's similar numbers on different parts, but different numbers on others, then they're different shapes. They're different size in different ways. So that's really cool. I hope that this has been entertaining, educational for you guys. Hopefully you guys can walk through this on your own. And I want you at the end of this to go, I'm proud of myself, because you can do this now. You can do this. This is easy now that you actually understand the data. So let's look at the medulla. The medulla. So that's between 39 and 46. $39 and $46. Okay, so when you go down to 42, make sure we can see that. Get right in the middle. Okay. So it looks like the day gecko has a bigger medulla. But yet, different sizes, different shape of medulla. So the medulla is different shapes here for the day gecko and the tokay gecko. So this explains why the tokay gecko hides more and probably loves having something touch its top and bottom. This is something we find in skinks and monitor lizards. That I have found in skinks and monitor lizards have something touching the top and the bottom. So if you look at the skink's medulla, so the medulla is more comparison from the skink to the day gecko than it is to the actual tokay gecko. It's really interesting. And the medulla of a bearded dragon compared to the day gecko is very, very similar. Very, very similar. So, okay. So the day gecko, and you got to remember the day gecko is a lot smaller than a beardy. So that shows a lot right there. So the beardy is a little arboreal, a little bit. And that explains that. But why the tokay is smaller, and so it probably doesn't have as deep of a hump as you might find in, because they don't really have that either. So maybe we'll look at the cerebellum here in a minute. So the cerebellum's the rest of it. So from here on out, so from landmark 47 to 61 is actually the cerebellum. Cerebellum is the only thing that they have found in this study that is truly locality wise, and they broke it down into limbless, reduced limbs, arboreal, terrestrial, and multiple. And so the sizes and shapes are actually massively important for this one. But that's part of the study. And we can see the tokay. Wow, that's tiny right there. So the tokay actually has a much smaller cerebellum in spots, which is interesting because the cerebellum is supposed to have language in it. But this might actually explain a lot too, that they are... Let's look at the skink. Definitely different shapes. The cerebellum is definitely a different shape to the skink, and the skink is a lot more. That's really fascinating. Wow. Okay. So what's this landmark? 50. Landmark 50. Landmark 50 on the cerebellum. Right here. So at this angle, so is it this? Is it this? Okay. So somewhere along this line here, whether it goes this way or this way kind of thing, there's something here in this size difference. That's massively different. That's really fascinating. They found the limb stuff limbless, folded backwards. So it took this shape. So the stuff with quadrupeds and stuff folded over the optic tantum and was actually much thicker for the cerebellum. And so you'll see that. So, yeah. Let's look at the snake and the cerebellum of the snake. The 45 is the ball python. So it's definitely a different shape than the ball python. The ball python actually has an overall bigger cerebellum than the tokay gecko. This is fascinating. I am very curious about this. We will look into this. We will use this data and look into tokay geckos, because tokay geckos seem like an outlier. Like, this is definitely an outlier for what they are. So they'll use so what we figured out here. So hopefully you guys have actually found this to be rather entertaining, helpful. I want you to feel proud for staying this long, and I want you to go back through and look at the data of the different species, because it's crazy. We have Jackson chameleons, all sorts of stuff in there. It's really, really cool. And you could just follow along with what I was doing and then just take off from there. And I would love for you to comment or write to me directly, because I would love to hear from you what you saw. if you saw that this was different. And it's not really something that you have to be like, oh my God, like I have to know exactly this and this. Like, no, you really don't. Like, you just see the numbers and see that this number is bigger than this number. So then as you look at these different landmarks, you can see, okay, so all these numbers are bigger than all these numbers. So this is actually bigger in this animal than it is in this animal. But if the numbers, some numbers here are bigger than here, but yet smaller here than here, then the overall is bigger here, then this is actually a bigger portion. And so they use more than this does, but they're different shapes, which is really fascinating. That's reverse engineering a study. That helps you to learn what these animals do. And I've actually learned a lot about tokays. Like, that's really fascinating. They seem to be an outlier from my understanding of how these parts of the brain work and stuff. I would have figured it would have been bigger than the day gecko. But if they spend a lot more time hiding, if they spend a lot more time between things. So this is why they probably like to cuddle together, because they have something touching. It's more comfortable. So wherever they're from, they might be preyed on a little bit more. So they want to hide more than day geckos are. Really fascinating. There's a lot of things there to actually look at. So that's why the tokay gecko probably gets scared so much easier. And it's defense because it's not fast enough. Its medulla and cerebellum are not equal to a day gecko. So day gecko is probably going to have faster information going that allows it faster reactions. But the tokay gecko hides more, probably hides more. So it doesn't need it as badly. And so its sight doesn't need to be as good as a day gecko. And that's why they get scared so easy if there's fast movement. That's really cool. Hopefully you guys could let me know. Hopefully go back, look at other things. I really want you guys to learn that this is not that difficult. It's biology. This is not rocket science. Trust me. It is as simple as looking at the overall comparison of numbers to other numbers to the species that are on that list, and you can start to figure out things. Thank you all for coming. I appreciate every single one of you. You guys have a great day. And I'm going to go to the show today. Yes! I am looking for mountain horn dragons, Peter-banded skinks, especially females, and Snyder skinks. If I can't find those, Chinese water dragons and Cuban nightingales, some females. If I can get, that's what we're looking for today. And like I said, I might be helping US Arc. So you guys have a great day.